Welcome to the Introduction to Calculus. I'm Mr. Stark. In this video, we'll be wrapping up topic 3, which is titled More on Limits, and we'll be working through lesson 3C, Infinite Limits. You can follow along using this document, which I have conveniently linked in the description. Let's get started. Let's learn about limits at infinity, shall we? When I say limits at infinity, what I mean is either x approaches infinity or negative infinity, or the function approaches infinity or negative infinity. The result of a limit is infinite. For negative infinity, we have the limit as x approaches negative infinity of f of x equals L. What that means is f of x gets arbitrarily close to L as x approaches negative infinity. Remember how that word arbitrarily showed up in our limit definition. It's important that we use it. For positive infinity, we have the limit as x approaches infinity of f of x equals L. And what that means is f of x gets arbitrarily close to L as x approaches positive infinity. Notice that we're describing the infinite limits similarly. Now let's do an example for each. For negative infinity, find the limit as x approaches negative infinity of sine x over x. In a previous video, we took the limit as x approaches 0 of sine x over x, and we got 1. The result of this limit is quite different. The first approach to calculate this limit is algebraic, but there are no properties or algebra that we can use to rewrite this expression in a different way. So we turn to a numerical approach. A great way to do this is on the TI-84 calculator. We enter this function into y equals in radian mode and then press second graph for the table. If your x values are changing by something smaller than 1, then you should change your table setup by pressing second window and change your delta table to 1, or even 5 would do the trick. So we go back to our table and we just keep pressing the up arrow to make our x values more and more negative. What we're doing is letting x approach negative infinity. We scroll up and up and up, let the x values get smaller and smaller and smaller, more negative and more negative and more negative, until we start to see a pattern in the function values, the y values. Then we ask ourselves a question. Is the function value getting arbitrarily close to a specific number? Something like 1 or 10, or in this case, 0. Even though x is approaching a number that's not real, negative infinity, sine x over x is approaching a real number, 0. And that's the answer. For the positive infinity example, find the limit as x approaches infinity of sine x over x. We'll take a similar approach, except this time, let's use a graphical approach. If we want to confirm what we see in a table, we should check out the graph. So with sine x over x saved as y1, we could simply press graph. And depending on what your settings are, you might have a regular viewing window or something different. But now let's press zoom trig. It makes the window more focused on the function. Then press the trace button. Your calculator will plot a point on the function, basically as your cursor, and then you could use the left and right arrows to let x approach infinity. Keep pressing the right arrow until you start to see the function's value converge or approach a specific value arbitrarily. So in this case, that value is 0. We kind of knew that already just by what we expected from the table and maybe just looking at the graph originally, but who knows? It could have been 0.1 or 0.5 or something like that. Another thing that you could do on your main screen is simply plug in values into the function by pressing alpha trace, and you could plug in something like 100 or 1,000 or 1,000,000, and you would see that the results from your calculations would be really, really close to 0. Now let's talk about unbounded limits. It's the other way. Instead of x approaching infinity, it's the function that's approaching infinity. In both examples, we're working with the same function. So let's first plug in this function into the calculator. I'm going to y equals, I'll just clear out what's there, and then enter 1 divided by x minus 2 squared with parentheses where I put them on the screen. Now let's go to your table by pressing second graph. If your delta table is 1, that's perfect right now, because when I look at x equals 2, I see an error. And that's fine. That means the function is not defined at x equals 2. But we're finding a limit from the left side and the right side. So x is approaching 2 from the left side. Well, let me go to x equals 1. I notice that the y value is 1. And then let's go to x equals 3. I notice that the y value is also 1. So I might be inclined to say that the limit is 1 because on either side, the value is 1. But we need to look closer. So let's press second window, and we change our delta table to 0.1. And let's actually change our table start to 2, and then press second graph. Now press the up arrow a few times, and you'll see x equals 2, and there's still that error. But now if we look at 1.9 and 2.1, we see that the function's value is 100. Interesting. So does that mean the limit is 100? Well, it was 1, now it's 100. Let's look even closer. Second window, change your table start to 2, change your delta table to 0.01, and then press second graph. This time, so I arrow up a few times, I'm looking at 1.99 and 2.01 on either side of 2, and I see that the function's value is 10,000. Because the function value keeps changing on me, I'm thinking two things. Number one, the smaller and smaller I make my delta table, the higher and higher those function values are going to become. So the next one might be 1,000,000 or something. Also, it's telling me that maybe I should look at my graph to see more of this function. So let's do that. Let's press Zoom 6 to get a standard viewing window. Then press Trace. It doesn't matter where your cursor ends up. Just make sure it's to the left of 2 because we're taking the left-hand limit. Then arrow right, approach 2 from the left side. And as you do that, notice what's happening with the y values. My y values are getting bigger and bigger and bigger, but they really only go up to 1,089. And then after that, I jump to the right of x equals 2, like 2.12, and it goes back down. So I'm starting to get the feeling that the limit as x approaches 2 from the left side is infinity. And you know, from the graph, I don't actually know if the curve connects up at the top, if it just goes up and there's an asymptote, or it goes up and curves back down. But there's something else we can do. And I know I'm getting like really focused in on this one thing, but let's press second trace value and type in 1.999999999, as many nines, maybe like 10 nines or something. And what I get on my screen is x equals 2 because it's rounding. It could only fit so many decimal places. But then for the y value, mine says 1e22. And what that means is 1 times 10 to the 22nd power, which is insanely huge. It's approaching infinity. And that's the answer to the left-hand limit, infinity. For the right-hand limit, we're not going to go through all of those steps again because we could clearly see from the graph that if we approach 2 from the right side, a very similar thing will happen. So we could press second table and we could go to x equals 2 and then see how the y values are big on the right side. And then we could go back to the graph, press trace, make sure we're on the right side of 2, and approach 2 from the right side. But again, on mine it only goes up to like 68, so then we could press second calc value and type in 2.000001. And then you should see that that y value is really, really big again. For me, I plugged in 5 zeros before the 1, and then I got 1 times 10 to the 12th power, which is really, really big as well. So the limit as x approaches 2 from the right side of this function is also infinity. The last thing I have for you is an exploration about the logistic function. Let's set it up, and then I'll have you try it on your own, and then I'll have the answers on the screen as well. So we have a function 50 divided by 1 plus 2 raised to the 3 minus x. So put this into your calculator right away into y equals. And then number 1 says use tables and graphs to find the limits. Well, before you even do that, what you need to do is set up your window so that you could see the function. So let's change your window. And if you have a standard window, negative 10 to 10 for x's and y's, all you have to do is change your y max to something like 60. Anything bigger than 50 will do. And then just press the graph button and you'll see it. I recommend using the table feature first to analyze the function and possible limits. Then look at the graph and use the trace feature. For number 2, identifying horizontal asymptotes, there are 2 of them, and horizontal asymptotes are defined by an equation, y equals something. So try to find those 2 and then answer question 3, how the numerator of the fraction for f is related to part 2, the asymptotes. Okay, pause now and I'll have the answers in a moment. Oh, hello. Maverick and I were just hanging out, waiting for you guys to finish that lesson. I hope it went well. Both of us really hope that you learned quite a bit about limits and you feel comfortable with them. So that's the end of topic 3. In the last topic, we'll study numerical derivatives and integrals, which will require the use of your calculator. Do you have anything to say? No? You're good? Okay. So I hope you'll join me for that one, and if you have any questions or comments, you can add them below. Thank you so much for watching. Boop. Oh, hey Maverick. We were just wrapping up topic 3C, so, do you have anything to add to the conversation? No? Okay. Boop. Oh, hello. Maverick and I were just hanging out, waiting for you guys to finish that lesson. I hope it went well. We're just here, snuggling, as you can hear. Boop. Oh, hello. Maverick and I were just hanging out, waiting for you guys to finish that lesson. As you can hear, he's pretty cozy and snuggly. Maybe? Boop. Oh, hello. Maverick and I were just hanging out, waiting for you guys to be done with limits. How'd it go? Oh, okay. Boop. Oh, hello. Maverick and I were just hanging out, waiting for you guys to finish up that limits lesson. That's the end of topic 3, Boop, boop, boop. Oh, hello. Maverick and I were just hanging out waiting for you guys to finish that lesson. I hope it went well. We're just here, snuggling, as you can hear. Oh, hello. Maverick and I were just hanging out waiting for you guys to finish that lesson. As you can hear, he's pretty cozy and snuggly. Maybe? Oh, hello. Maverick and I were just hanging out waiting for you guys to be done with limits. How'd it go? Oh, okay. Oh, hello. Maverick and I were just hanging out waiting for you guys to finish up that limits lesson. That's the end of topic 3,